Alright guys, here we are with section 5.4. We're talking about analyzing graphs today. The first kind of thing we're going to be talking about here is relative max and mins. These are going to be all of our mountain tops and valley bottoms. And they're called relative max and mins because they're not necessarily the maximum value or the minimum value. Okay, but all our mountain tops are going to be relative or R maxes, and all our valley bottoms are relative or R mins. Okay, and again, that's because this is not the lowest value. This goes down forever. But this is the bottom of a little valley here. So this is the low point in this area, and this is the high point in this area. It's not the highest point, and neither is that one. This arrow goes up forever. So that's why they're called relative. They're the lowest point in that relative area. Okay, when we're graphing today, we need all of our intercepts on the x and y axis, all of our relative max and mins, and then we need to graph it so it looks pretty close to what the graph on the calculator looks like. Alright, number one for us today is very similar to, I think it's exactly the same as example 1 in your textbook. Alright, so we're going to type that into the calculator. Negative x to the fourth plus x to the third plus 3x squared plus 2x. We're going to graph away. Alright. We got a quick little squiggle here, and then it goes up to the top and back down. Alright, so what we're going to need is we're going to need all our nice points, negative 1, 0, 1, 2, and then we need to go through also and hit all of our zeros and all of our y-intercept and our maxes and mins. So you could go to a table, second table, and get your nice points there. It looks like we're going to have negative 2, negative 16 is going to be off the graph, negative 1, 0, 0, 1, 5, 2, 8, which should all be nice, and then 3, negative 21 is going to be off the graph. So we only have a few nice numbers there that are going to work for us. Okay. I just go from the trace menu, just hit trace, alright, and then I'm just going to hit negative 2, enter, and it's negative 2, 16, negative 16, so it's going to be too far, it's not going to be on our graph. Negative 1, enter, negative 1, 1, negative 1, negative 1, excuse me, 0, enter, 0 is going to be at 0, 0, 1, enter, 1 is going to be at 5, 1, 2, 3, 4, 5, 2, enter, 2 is at 2, 8, and you can kind of see that that is not quite the highest point. We're just past the tip of the mountain there. So we're going to have to go back and find what that high point is. 5, 6, 7, 8, 3, enter, 3, negative 21, so it goes down real quick after that. Alright, so my y-intercept and my x-intercept are the same at that one, 0, 0. So the only other really extra stuff I need is my mountain top up here, my maximum. And then I need my x-intercept there, my 0. So second trace, maximum. Gotta find your guy. Alright, left side of the top, right side of the top. Guess in the middle. It looks like our maximum's at 1.8, 8.7. 1.8, 8.7. And if it's not a nice one, let's go ahead and we'll put those coordinates on there somewhere. If it's not a nice, like, negative 1, negative 1, something that's going to fit right there, and you can kind of tell what it is just by looking at the dot. If it's kind of in the middle of our grid, then you got to put that down there. Okay, and then our other point we needed was our x-intercept there. So those are zeros. Left bound, right bound, guess in the middle, 2.5, 0. that's 2.5, 0. And then it goes down real quick. Alright, so it's kind of slow, so there's a little mini loop kind of thing there. Up to the top, back down, and this is going down super quick. Alright, so there it is. We've got all our x and y intercepts. We've got our relative max and mins labeled. And we have intercepts, max and mins, and it looks pretty much like the one we have on our calculator. Pretty close. Okay? So, let's zoom out here, and if you have a graph paper with you, or maybe just sketch it there on your piece of paper, let's have you go ahead and hit pause and get after number 2 there. Okay, welcome back. Let's take a look. So this one had a few more dots to go after. Alright, it looks like we are going to be at -1, 1, 0, 1, 2, 3, 4, 1, -1, 2, -2, and then we're going to take off and go up pretty quick over here. And then we had to go back and get our zeros. It was really close here, but it wasn't exactly at -1, 0, because -1 was at 1. This is -1.08, 0, or -1.1, 0. Our maximum looks like that is at -0.3, 4.5. Our other root over here was at 0.8 or 0.81, 0. Relative minimum, 1.64, -2.86, or maybe you had 1.6, -2.9. And then our other 0 up here was at 2.27, 0, or 2.3, 0. And I didn't get what the third one, what 3, would be. But you guys got the idea there, and that should look pretty close to what your calculator looks like. So that one had a little more work to do to go back and find some of those numbers. Okay, what else do we have? Alright, so this is going back to our even and odd stuff that we briefly talked about before. Okay, remember that odd, the arrows are going to be going opposite ways. One's going to be going up, one's going to be going down. Okay, this is going to have roots at -3. No. -3, 2, and 5. And another thing we need to talk about is smallest possible degree is going to equal your number of turning points plus 1. Alright, and that might be a little confusing to you now, but it'll be common sense here for you real quick after we take a quick look at one of these problems. So I need to cross the x-axis at -3, 2, and 5. 3, 4, 5. Okay? When it says those are my roots, those are my zeros, I need to cross there, and it needs to be odd. Okay, the in-between stuff doesn't really matter. You just have to give a quick sketch of a graph that would meet these requirements. So something like this. It's odd. One arrow is going up, one arrow is going down. And we cross at -3, 2, and 5. Now turning points, those are your maxes and mins, because I'm turning around and going up, and now I'm turning around and going down. So here's one turning point. I'm going down, I turn around and come up, there's another turning point. Okay? So there's 2 turning points, plus 1 would mean my smallest possible degree would be a degree of 3. The smallest possible degree would be x to the 3rd. That's what this is saying. It could be an x to the fifth, it could be a quick little mini squiggle in here. Alright, but the smallest possible degree it could be is x to the third. Alright. An even function with a relative max at x equals 2 and a positive leading coefficient. Positive leading coefficient, alright? And it has a max. So if I was going to do x squared with a positive leading coefficient, that means it's going to be going like this, and I'm going to have a low point, a minimum. Alright, so how could I do that? I can't really do that with an x squared, so we're going to have to think bigger. We're going to have to think x to the fourth. That's even. If I had a positive, it means my arrows are going up, but an x to the fourth is going to have a little w action to it. Alright, and there would be a relative maximum. So we're going to go with x to the fourth. And this needs to happen at x equals 2, so somewhere on the x equals 2 comma, whatever you want to make your maximum be. Okay, I'm just randomly choosing 2 comma 1, 2, 3, 4, so 2 comma 4. And it's going to be even. So and it's got to be a positive leading coefficient, so both arrows are going to be going up at the end. So if I'm going with x to the fourth, I'm going to have a little w action, so this is going to come down and back up over here, and this is going to go down and back up on this side. So there would be 1, 2, 3 turning points, 3 TPs, plus 1 would mean the smallest possible degree we could do this with is with a fourth degree, or an x to the fourth. Okay, and we kind of also talked about why that would be the smallest possible degree you could do it with. You couldn't do it with an x squared and meet these requirements, having a positive leading coefficient and be an even function with a relative max, because if you did a positive leading coefficient with an x squared, you'd have a bottom. You'd have a r min, not an r max. So, and then to the third power, that's not even. So the smallest even one that we could meet these requirements with was an x to the fourth. Okay? And then another problem that you're going to have towards the end of your assignment is that the book's just going to give you a graph, and you're going to estimate the coordinates of all of these things. You have to estimate the relative max and min, estimate the coordinates of the zeros, okay, determine the smallest possible degree it could be, and we're going to do turning points plus 1, and then give the domain and range. Okay? Most of these in the book are going to be pretty nice, obvious things. Some of them you're going to have to think a little bit. Okay, it might not be exactly 1 or 2. It might be at like a 1.5. You're just going to have to do the best you can. Alright, there's going to be some flexibility on these answers, but I'm going to try to do one here for you. It should be pretty obvious. And by obvious, I'm meaning I'm going to have nice dots here for you. Alright, make a smooth curve out of this. Okay, we'll do the best we can from there. Light blue, probably not the best choice. So you can kind of see that. Okay, estimate the coordinates of our turning points. So there's a turning point, and here's a turning point. Let's estimate those coordinates. I've tried to be real obvious with those. That's going to be at negative 2, 1, 2, 3, 4, 5, 6, negative 2, comma 6, and that would be an R max, relative max. You can abbreviate relative max, relative min by R max, R min. Okay, my other one I have down here is at 1, 2, 3, negative 1, 2, 3, and that's going to be an R min. Those are my turning points. estimate the coordinates of our zeros or roots. Okay, those are going to be at negative 1, 2, 3, comma 0, 1, comma 0, 2, 3, 4, comma 0. Or they might, in the book, it just might say x equals negative 3, 1, and 4. Smallest possible degree. How many turning points are there? 1, 2, 2 TPs, plus 1 would mean this is the smallest degree this could be is a third, x to the third. Excuse me. And domain and range. Okay, it's always good to talk about these. Domain, what x's are getting used. Alright, if we can see the arrow over here, we're going to be going up and out forever to the right, and then down and out forever to the left. So our domain is we're going to keep going out forever this way and out forever this way. That's going to be all reals. And then also for our range, this arrow is going up forever, this arrow is going down forever. That's also going to be all real numbers. Okay? I would imagine most of these are going to be all real numbers on the domains. The even ones are where you're going to have to watch your range. Okay, example, let's look at, we had something like this. Alright, there's our R max, but both arrows are going up forever. Here's our R min, this is the lowest as we're going to get. So then our Y's would be this number or higher. Y is greater than or equal to whatever that Y number is. Or it could easily go the other way, it could be like this, and then all our Y's are this or lower. Y would be less than or equal to whatever that is. Okay? Alright guys, good luck with the homework there, and let me know if you have any questions.